the best answer that I got was someone quoted Dr. House from House MD, everybody lies. So you got to have that human level trust. So it's great to have, you know, the face and the name behind some of the development so that those of us in the aerospace community can know one another, trust one another, understanding that the systems we develop won't be perfect, but that trustworthiness is really a human to human kind of thing that we need to emphasize.
Hello, and welcome to the Space Policy Show. I'm Colleen Stover with the Center for Space Policy and Strategy, part of the Aerospace Corporation. You can subscribe to get notified and learn about the Center's deep research and reports at csps.aerospace.org. Today, we open up with a look at artificial intelligence. AI, what is it? What is it not? How is it used in the space sector? How could it be used? And what is the role of trust, especially in space systems? So I'm happy to have our guests today from Aerospace Corporation, and I'm going to ask each of them to introduce themselves. So I'll start with you, Katie.
Hi, my name is Katie Melbourne, and I am a policy analyst here at the Center for Space Policy and Strategy at the Aerospace Corporation. I recently just wrapped up my master's degree in aerospace engineering, and my bachelor's is in astrophysics. And so this has really exposed me to a lot of the algorithms behind some of the concepts we'll be discussing today.
Thank you. Next.
I'm Pamela Wood. I work in the Vehicle Autonomy and System Trust Department here at Aerospace Corporation, where I'm leading research into integrating AI into autonomous decision-making and autonomous systems, and really focusing on that trust element and how we can start moving that forward for the space industry. My background is in industrial engineering, data analytics engineering, and I'm currently pursuing a PhD in computational sciences and informatics.
Wow, impressive, Pam. Next, Paul.
My name is Paul Frakes. I'm a systems engineer and foresight practitioner at the Center for Space Policy and Strategy. So my background is in aerospace and systems engineering, but in my role as a foresight practitioner, I help our customers at aerospace to field capability under uncertainty. So we've definitely been tracking developments in artificial intelligence to help folks understand how it can be used and what the limitations are.
Thank you. Thank you. And I know we're going to get a little bit into that strategic foresight, which is your forte, as we go into the conversation. So I appreciate that whole element of uncertainty. And certainly AI is that. We're not really sure where we're at, right? So like any good discussion, I want to kind of start off by defining our terms. And I'll start with you, Pam. What would you say AI is and what is it not? Like, what do people typically get wrong?
I think the most common thing that people get wrong is confusing AI with autonomy. These are two different concepts and also distinct disciplines. AI is the ability of computers to perform tasks using human-like intelligence, right? And that's why we start to recognize them as sort of sentient in nature. Autonomy is a little different in that it's defined as the system that can function to perform tasks and achieve goals that are bounded by authority that the humans give it. But the key component to autonomous systems is that they operate with some level of self-sufficiency and independence over external control. So quite often, AI really enables autonomy, whereas AI isn't autonomous unto itself, right? So you have to delegate that authority to the system to make that decision. And so that's quite often why these terms get conflated, but there's specific technological components to each and requires very focused discipline on both.
Interesting. So the idea that AI is not autonomous is something, because I mean, that's what we're all worried about, right? Is that kind of, rage of the machines and sentience and
Correct. Yeah. And as I talked about, I focus on trust, right? And so along those lines, my family actually jokes that I really want it to be sentient and have those things start to happen. But the truth is that when you start to integrate into systems, you really architect them to allow that behavior and that effect to occur. And so I can appreciate, the science fiction side of this, but when we start getting into the physical integration and thinking through the system designs, as I'm sure Paul can appreciate, it's really hard for AI to get to that point, nor do we really have the technology quite yet. I think the chat GPTs of the world are doing a really great job of maybe confusing us and making us think they're a little farther along than what they are.
Interesting, interesting. So, Paul, I know that you and Katie recently put out a paper through the Center for Space Policy and Strategy, and in that, you guys differentiated between kind of different levels of intelligence, if you will. Could you walk us through that a little bit?
Sure. Yeah, there's a number of different ways to try to provide a taxonomy of terms. Um, some that we allude to in the paper are narrow AI, which is using new AI technologies like transformers and that sort of thing that people are familiar with through large language models to do a specific task in one specific domain of human activity. In theory, there's a broader, what some people call artificial general intelligence, the ability to abstract and take lessons learned from one domain and apply them in another domain. And one of the taxonomic structures that we provide there in the paper lays out different levels of maturity for narrow and more generalized AI, and provides a structure for understanding, where certain specific applications of AI technologies are in their maturity relative to others, because it is a mistake. One of the big themes of our paper is it's a mistake to say that AI for space is one big monolithic thing. So one of the things that we emphasize there is that if you say you want to use AI for space, I'm immediately going to follow up with, well, what do you mean by AI? What are you actually trying to accomplish? What technologies are you using? What is your mission that you're trying to accomplish? And with additional granularity, we can start to understand exactly what it is that we're trying to do, rather than having this sort of abstract notion of a generalized machine intelligence that we don't understand.
Yeah, no Terminator yet. No Terminator yet. So things that I wrote down, in terms of AI was it's used to kind of predict, recommend, decide. It provides information. It provides action. Um, Katie, can you do you have anything that you wanted to add in terms of what we might be missing for what AI is, or what you hear people get wrong even more so?
Yeah, so I love both of those answers from Pam and Paul. Getting confused between autonomy and AI is actually my pet peeve and kind of what brought me into this project, because I have written autonomous algorithms through my classes for my studies in aerospace engineering, but they don't use AI. And I have used AI algorithms that are based on machine learning in astronomy that don't necessarily, work entirely on their own. So it's this push and pull, and I think both Pam and Paul got to that very well. I think the other thing that we need to point out is the use of AI to not just predict but to classify. That was a big thing that we used it for in astronomy, in particular. That's the machine learning. What machine learning was used for, where we would take these massive data sets and they were either labeled or unlabeled, and we could use machine learning to classify them and pull out new insights from that data. So I think both Paul and Pam got to this, that you really have to be specific about what you're trying to use AI for. Is it going to be to make a system more efficient, more autonomous, or is it going to be to aid a human in their decision making and glean new insights from massive amounts of data? So I just want to reiterate what they were saying.
Yeah, thank you. Thank you. That's good. It's all good points.
Yeah, before we move on, I think one of the things that the nuance with what Katie just said and kind of bringing in what Colleen said The difference really between the two systems is that autonomy gives you the ability to act, right? AI by itself doesn't have the ability to act. It can give you those recommendations. It can give you that insight into things, but until you put it into a system that has been delegated some level of authority, either distinctly with code or mechanically, it doesn't have the ability independently to act.
That's a really good point, right? Yeah. So the AI actually feeds into autonomous systems and can beef them up a little bit instead of the autonomous system just relying on what it knows, what's already been pre-programmed with. You can use AI to feed into it so that it can do more autonomous stuff.
Right.
Okay, so I wanted to move on a little bit. So, Paul, I'm going to ask you to start this off. In the paper that you and Katie did, you guys drew out a number of ways that artificial intelligence is used in the space ecosystem specifically, which obviously we're an aerospace company, so we want to talk about that. Why don't you talk about some of the ones that you find most intriguing, and if you can, even offer some benefits and risks of some of the ones that are your favorites?
Sure. Yeah. In the paper, we highlight a number of mission areas that are already using certain types of artificial intelligence technologies, both in space and on the ground, in order to achieve their missions. So we talk about workforce augmentation and human machine teaming, some of the ways in which humans are using algorithms that have been developed by AI in order to accelerate their tasks that they perform, while still retaining that decision authority they have to complete the task and make the final decision. We also highlight remote sensing and some of the ways in which machine learning algorithms on the ground are helping citizen science take data that has already been downlinked to the ground and sort through that in faster and more efficient ways in order to find some really interesting insights. And I know that Katie has some experience with that in the astronomy field as well, using algorithms to look through data in ways that we wouldn't otherwise be able to do just with humans alone. And then one that's interesting to me is the space traffic management aspect. So I actually used to do on-console space traffic management work at a previous job, and so it's been really interesting to see how the manual tasks that I used to have to do in assessing individual data points and velocity vectors can now be, at least to some degree, automated or accelerated through the use of these larger analyses of big data sets using AI generated algorithms.
Interesting, interesting. So, Katie, did you want to dive in a little bit on your experience more with astronomy? What's something cool that you've done with AI?
Well, so actually, I was going to jump off on Paul's space traffic management comment
Yeah, go
because
for it.
it's really interesting to me how AI can be used in different aspects of that entire process, right? So there's everything from, pulling and putting together all these different types of data from different sensors, and then using those to search through and find conjunctions, and then autonomously, notifying operators when there's a potential conjunction. But it's important to note that part of that process is still manual, where the operators still have to contact each other and negotiate who has to maneuver. So that is actually one of my own areas of interest. So really interesting to look at where AI could be used and where humans are still very much in the loop. And also related to that, and related to my work in astronomy, is combing through large amounts of data, like I mentioned earlier. So I'm particularly interested in space domain awareness applications for AI. So looking at when spacecraft have made maneuvers that are maybe beyond the typical station keeping that you'd expect, and we can point out
Can I
those.
just ask, let me just ask you to clarify, just for our audience, the difference between what Paul was talking about, STM, space traffic management, and then what you've just started with space domain awareness. Like they're
Yeah.
both looking out and they're both looking at stuff moving around and trying to make decisions, but how are they different?
That's a great question. Yeah, so space traffic management is going to be more of the active process of deconflicting conjunctions and making sure that you are communicating where you are with your object in space. Whereas with space domain awareness, you're trying to figure out both what is going on in space and what are different actors' intents. And that can be everything from like what are satellites actually doing themselves to space weather. So there's a lot more. It's kind of a broader thing that supports space traffic management. And Paul,
Right.
jump in if you have more things specifically to say about that.
I'll jump in as well because there's an interesting challenge with respect to really being able to use AI to do some of those space traffic management tasks, namely a lack of data. So if you mitigate all of the collisions by maneuvering out of the way, then the close approach data that you would have had otherwise doesn't exist. You've already moved your spacecraft. So that's one really interesting challenge that we highlight in the paper. And we've got some references there in the back for folks who are interested to read more about that. I think that's actually one of the things that I find most valuable about having collaborated with folks here is just being able to assemble all these references together in one place so that we can sort through what's AI, what's not, and how's it being used.
That's interesting. So the more things you correct, the fewer mistakes you have to learn from.
That's right.
Yeah. And what's interesting about that, Colleen, is it's and Paul's mention of that is it's a constantly changing dynamical system, right? Where there's a lot of actors in space and there's a lot of things happening in space, either with control or when we start talking about orbital debris, right? Those orbital debris is something we can't control at this point, and that's part of the conversation that's on the front for the in-space servicing, assembly, and manufacturing community, really speaking about how do we start thinking about solutions for orbit debris, not only from a tracking and awareness perspective, but can we start to remove these things? Now that we've gotten to these technologies where our vehicles can operate with precise robotic maneuvers in space, maybe we have some solutions that we could start deploying I'll say, as an entire space community worldwide to deal with that problem. That it's not an issue that affects only one of us. It's an issue that affects anybody operating in space.
Yeah, and I know the US has recently announced that it wants to be a leader in that.
Yeah, there's so many ways that AI is getting integrated into our space systems. I mean, they highlighted some, but anywhere that massive amounts of data are available and can help humans digest them into I'll say human understandable formats, right? So big data is hard because we can't process as fast as computers can, and so there's always opportunities there. Growing areas are anything related to resource management. So we talked about maneuvers. Well, that's related to fuel management for spacecraft, right? So you could create an AI system that can do predictions on when and how to best optimize your use of your propulsion. Because until we get to refueling on orbit, you only have so much. So you have to decide. And so people with remote sensing applications start to think about resource management with regard to scheduling and planning when they do their collections for remote sensing, either for intelligence purposes or weather purposes. So there's so many areas of opportunity for the space community at very low levels where AI is starting to emerge.
Can you give us the remote sensing? I'd like to pick apart a little bit more. You mentioned about security, and of course, you know, there's the satellites that look up and out and around up in space, and then there's the satellites that are looking down. Besides like national security purposes, you know, where the troops are, where the tanks are lining up on a border, you know, like that. What other ways is remote sensing and AI used?
One of the things that the space community is starting to get more integrated with, I'll say the naval community or really shipbearing. There's a lot of commercial traffic on the ocean. Um, And while we can think about it from that perspective, those oceans are pretty large, right? And so if you can't see what you're about to run into, and sometimes you've got bigger ships that have a hard time turning. So there's a lot of AI being used with remote sensing as well as maybe signals, that's using to process just commercial traffic through common waterways. And that's not for intelligence gathering purposes. That's just for navigation and safety purposes and access.
Talking about areas of high potential, I just want to piggyback on the mission management that Pam mentioned. So I'm also really interested in the use of AI for deep space exploration and these being scenarios where you might have limited communications with, a ground station on Earth. And so how can you use AI to explore a different planet or moon in our solar system and get new insights that we couldn't get in human-centered operations? So there's all sorts of potential with mission management in AI, as Pam mentioned.
Well, and we've been using, the rovers on Mars have used AI, is that right?
Mhm. Yeah, and to Katie's point, mission management is actually where we're seeing the most growth in AI-enabled autonomy, is more towards onboard mission management, which is very similar to what you said with the rovers. It's that ability to access and operate through communications with the ground dependency that we currently have. So those onboard mission managers are quite often AI enabled, but reinforcement learning has created an opportunity for that adaptation in those kind of deep sensing or deep remote environments where the platforms have the ability to adjust to the conditions that they're facing rather than the conditions that the humans thought they might face, right? So if we start to enable that technology, they can then adjust in real time.
Okay, so before we move to the next question, we haven't really talked too much about risk. I know, Paul, you had mentioned something about having too many correct answers, kind of messing up our future results when it comes to space traffic management. But are there other risks that we might want to mention before we move on?
Sure, certainly there's definitely perceived risks, and it remains to be seen how the space community is really going to work through those. I think most broadly, especially as we refer to workforce enhancements, there's maybe a perceived risk that AI is going to replace the human workforce entirely. And I think that one of the ways that we can approach that challenge is to understand where the limitations are and what it is that we want humans to be doing in terms of making decisions and being involved in the process, having accountability, especially as it relates to safety concerns, versus handing everything over to an algorithm or an agent that's purely computer. We've also got a number of potential risks related to data and data poisoning. If we look at the ways in which AI models are trained, they're trained on large data sets. So if you introduce either faulty data or misrepresentative data for the mission area that you're trying to actually build an algorithm to address a challenge, that could also introduce some vulnerabilities and some risks where the agent that you have trained is going to behave in a way that you didn't want it to.
Yeah, the hallucinating. Others?
So one of the things that I find interesting about AI and machine learning is that they will always give you a decision, right? Regardless, because they're running, right? So regardless, back to your hallucinations, regardless of what you ask and how much it actually knows, it's going to give you an answer, right? So there's a risk
That
to
sounds like my 2-year-old.
same, right? And my 16-year-old, right? There's an overconfidence that is a risk. And so one of the ways that we in the community are combating that is through things with AI watchdogs. And so there's technology that's emerging that has the ability to look internal to those models and identify specifically how I'll say how educated they are to make the recommendation that they're giving you, or make the statements that they're giving you. And so that's one of the things with regard to the space community that we're really focused on here at Aerospace, is helping our customers start to put those safeguards in place so that if you choose to use AI for mission management, for example, that we have the mechanisms that we can deploy alongside it that can tell you when you should switch back to a more classical technique, and do maybe maneuver at more of control algorithm that is not AI enabled, right? Just more physics based mathematics, as opposed to high end machine learning or artificial intelligence. So those are technologies that are emerging and things that we're really concentrating on here in the space community.
Well, thank you guys. There's definitely risks that people, beyond Terminator, there are risks, real risks that people are thinking about, but it also sounds like there's enough people thinking about how to manage those, which is our job, right? So as these capabilities, kind of keep evolving, I know you guys have talked about mission management, and that's really people are really moving into that, and it's being used a lot. Katie, I'll start with you. Could you maybe talk about what you think has the most potential in the space ecosystem, and maybe even what has the least potential?
Well, I think it's similar to what I mentioned before, is like being able to use AI in ways that are it's difficult to have a human operator. So things to make operations more efficient. I really like the idea of using it to plan. So something I think a lot about is dynamic space operations and what can we do to move and act more dynamically in space, whether that be maneuvering or tactically responsive launch, things like that. And I could see AI being really, really useful for things like planning launch schedules to make sure that we're optimizing for um, where we're sending things to what orbit at what times and what windows. So there's a lot of potential there, as well as mission planning when you're in an operation room, using AI to actually help you plan out maneuvers of satellites to optimize for things like efficiency. And it just allows people to still be experts in astrodynamics, but use use their expertise in conjunction with a tool that can help them be more efficient.
Yeah, no, that's a great point. Anyone, Paul? What's
Sure,
got
I
the
think,
most potential, or maybe the least potential?
yeah, I don't know about most or least per se, but I think one area of interest would be even just developments in AI and its application from outside of the space industry proper. Maybe a tangential area of maturity would be systems engineering. If I were to apply autonomy or AI technologies across the systems engineering life cycle, what are some additional, and this is a question that I ask myself as a strategic foresighter, what are the additional improvements or synergies or even transformations that we could see as we apply some of these technologies across the board to the way that commercial industry interacts with the government. We've already seen digital twins being delivered alongside physical products as part of a delivery for systems. So, as we accelerate the use of AI models being delivered alongside other deliverables, that could be an interesting development, or something that's not even space related per se. I think about the workforce of the future. The folks who are in high school and college now are going to be, let's call them LLM native. And so by the time they're mid career engineers, will they be looking at space systems engineering in a sort of different way than those of us who are already in the industry, because they've been using AI tools across the gamut of their life experience for so long?
Yeah, that's really interesting to be LLM native. I think we've just coined a new term. We better get a wiki page up quickly. Instead of digital native, right? I mean, they might be thinking of things in ways that, of course, we haven't even thought of now. Like we can't even imagine it.
Yeah, that's one of the things that I know as an autonomy researcher that we think about quite often is, and maybe I'm a maverick this way, in that I like to turn things on their heads and say, well, why do we do it that way? Um, it, I think one thing with mission management is we frame the design of those systems all around how we do operations today. But what if we're doing operations that are not optimal, right? Just because we've always done it that way doesn't mean that maybe that's the way we should keep doing it. So I think when you start thinking about deploying things on board a spacecraft, you are no longer limited by the data that you can bring down from space. You now can enable the opportunity for those algorithms to learn all of the data that's available to it on board that platform. And it may come up with something completely different that we never thought of. And so just because, the humans can do it, maybe we need to start thinking about what machines can do differently that humans can't do at all. And so that's some of the things that I'm most excited about with regard to the space community, because we've always been so limited in the past based on the amount of data that we could downlink and our access to that data. Those, I'll say, barriers are getting lifted. And I think that's enabling a lot of opportunities for artificial intelligence and autonomous operations. Katie triggered my excitement brain talking about responsive launch. My industrial engineering background took that all the way to the left and said, well, okay, let's just do just in time supplying for that entire pipeline and look at not only getting it to the launch pad, let's talk about the warehousing, the building, the manufacturing pipeline, and take that all the way to the supplier workforce. Artificial intelligence has so many opportunities in that space to really start putting all these things together from a predictive standpoint and start getting us and the space community out of reactivity and more towards proactivity and more forecasting and planning. And so there's a lot of really, really cool changes happening in the space community, that I'm sure is
Yeah.
going to make a lot of people nervous because we're moving
Well, yeah, like
fast.
even as you're talking, I'm thinking, what if there's another pandemic? What if there's a, like, how can you plan for the unplanned in that, right?
Exactly. But I think the pandemic is a good example. We all experienced some disruption with the auto industry in the pandemic
Yeah.
and all of those high-end parts that it has now become all of our creature comforts in our automobiles, in our cars, right? Well, the space community is subject to those exact same supply constraints. And so we need to start thinking about, maybe going back to your risks question, we need to start thinking about our supply lines and how do we start hardening ourselves against those disruptions. And AI has a key role to play in that.
Excellent. Yeah, thank you.
I'll piggyback off of that, even to stretch it one more step, looking at, again, not the technology, but the economics of AI. Not that I'm an expert in economics, but it is something that our foresight team tracks is, what are the challenges to the development of AI technologies or the supply chain, based on some of the economic constraints and the market forces that are driving development in this area. So that's just another domain to watch as we look at what could the future hold for AI.
Yeah, great point. I'm thinking, I mean, I'm personally, for me, I think about power sources and use of water, and how are we going to figure out on Earth how to continue, this big data processing terrestrially. And then, of course, you were talking about edge computing and the idea, I think that's what you were talking about, computing in space. Um, and what the power is going to look like there, and how we're going to kind of tackle some of that technological hurdles to be able to do that, these on-orbit data centers and stuff.
Well, and not just on orbit data centers. Now we're talking about on orbit nuclear reactors for power, right? So
Yes, yeah.
yeah, it's going to be an interesting future.
Cool. So I'm gonna change gears a little bit. Um, Obviously, one of the main risks is trust, right? We talked a little bit about hallucinating. We talked about some kind of dubious answers because the AI is going to provide an answer no matter what. So I know, Pam, this is your baby, trust, right? You've thought a lot about trust. So can you introduce us to this idea when it comes to space systems, AI, and trust?
Yeah, trust is a really complicated topic. So how I think of trust is along two veins. I think one is along the concept of assurance, and assurance is evidence-based, right? So if I can show you all of the data and all of the tests that show you that a system is trustworthy, right? That you should be able to trust it, and I have evidence according to that. Now, with these really complex systems, there's an element of uncertainty because we can't be 100% sure, but there's a lot of testing that we can do. Um, but that doesn't mean that you're going to take the leap of trust, right? That's a very human concept. That's a very like, am I comfortable in this domain? And that's very unique to each individual, right? So I separate the concept of trust into things that we can engineer and then things that are more human oriented, that we need to think about different processes such as change management and human machine teaming, and how do we evolve the workforce into maybe more advanced capabilities, right? So they're kind of two sides to the same coin. But the result of all of that is that trust is really multidisciplinary and it's really, really complex. And so we as a community need to start thinking about this, not just in our own independent technical disciplines, but start coming together in a kind of a heterogeneous format, talking about the systems as a whole with regard to trust, particularly when they have the ability to act independently of humans. Because what happens, and this is something that we wrestle with in the autonomy community, it's one thing to develop an AI algorithm, right? But you have to put that AI algorithm in some sort of hardware. It could be running on a computer on the ground, or it could be running on a robotic platform like a spacecraft. But there is hardware involved. And so then there's a whole other discipline that you have to really talk to and understand what are the limitations of that hardware, what are the barriers that the software is going to run into to make it fully optimal. So we've started talking about trust and trustworthiness as an entire system concept. And so it's really requiring us to start working together across a lot of disciplines, the systems engineers of the world, the aerospace engineers of the world, the propulsion engineers of the world, and they have to come into the same meeting room and talk about, well, if a software algorithm makes this decision, and these are all of the subsequent actions that occur in the system, what are the potential hiccups? And then we have to go back and test for those things, right? Before we even launch, before we can even assure ourselves that this system is trustworthy. And that's just in the design stage, right? So take that a couple steps further. These things now have to be sustained on orbit. So if we have the ability for these things with through things like reinforcement learning, or even leave those AI algorithms in training mode, they have the ability to adapt over time. Our testing is no longer valid once something changes, even in the slightest little bit. And so right now, the space community is dealing with that by making these models static. And so essentially what we're deploying is just this known model which essentially makes them discrete in nature, and we're able to understand what their outputs are. The math is totally complex. Don't get me wrong, not everybody's going to understand it, but those who are knowledgeable understand with the same with the input what the output will be, and we can test for that. When that changes over time, we have to have some sort of continual test process that frankly is still on open research questions right now. And so we're grappling with that in the space community. We're typically very trust averse, and so that's where those technologies I was talking about earlier with regard to AI watchdogs are going to become very critical, because those capabilities will enable us to know when our baseline understanding has really changed and when we need to go back and reassure ourselves that our system is trustworthy. I could
Yeah, that's
I could go on all day.
I know, I know. This is wonderful. So, but you're bringing back that idea of, because you're using this great thing called artificial intelligence to do things, it's changing reality, right? And so, how do you understand how it's going to change reality without knowing what it's going to learn? Right.
right.
Also,
And
Oh,
oh,
yeah,
sorry.
Katie.
oh no, I was just going to bring in that Turing quote. I think Pam and I, you have talked about this on the side before, where I think it's also a paradigm shift of the trust that we put in machines, right? We think that machines are these things that, once we program them to do one thing, they're infinitely good at doing that thing. Right. But I think the Turing quote is, if we expect machines to be infallible, then are they really intelligent? And so I might have gotten that a little bit wrong, but I think that the main idea rings true, where it's like, we can't expect something designed by humans to be 100% um, infallible. And there is going to be a need to understand the underlying amount of uncertainty that goes into the data behind these algorithms, into the algorithms themselves, and then into the execution piece of like what's actually happening. So yeah, I think Pam summarized it so well with hitting on each of those three aspects of trust in AI.
Yeah, Pam, I
Paul.
agree, and I think I'm very happy that you continue to emphasize the human element throughout your whole response. A little while ago, I had the opportunity to interact with some researchers doing human machine teaming research, and I posed the question, okay, for as deeply technical as you are, how are you accounting for human nature as you engage in designing these robotic systems? And some of the folks there just sort of gave me a blank stare. It's a very challenging thing. I think the best answer that I got was someone quoted Dr. House from House MD, everybody lies. So you've got to have that human level trust. So it's great to have, the face and the name behind some of the development so that those of us in the aerospace community can know one another, trust one another, understanding that the systems we develop won't be perfect, but that trustworthiness is really a human to human kind of thing that we need to emphasize.
Interesting. Yeah. So would you say, Paul, that like in terms of things that we really need to address moving forward with AI, there's technology challenges, there's workforce challenges in terms of bringing up the next generation of computer scientists. There's governance challenges, in terms of policies that come down from government. And then you just mentioned the cultural kind of human challenge. What do you think is there something that's more important than others?
Um, I think they're all important, which is a terrible answer to give. It's sort of the catch-all. But I will emphasize perhaps the cultural element of it. As you said, I think, um, yeah, just the keeping the human first, understanding that the algorithms that we're developing are not ultimately accountable for what they do. I think the people are going to be held ultimately accountable, just as a matter of how operations ends up working out. And if we keep that in the forefront of our minds as we develop these advanced systems, that will go a long way to establishing trust.
Yeah, thank you. Thank you. Katie, how about you? What do you think is most important to address now as we move forward?
I'd say workforce, and not just when humans should be making a decision and being put on the loop versus AI, but also what we should make sure that humans know how to do still. Just as Paul mentioned earlier, and we have LLM natives, growing up in our engineering classes, English classes, everything. We need to make sure that humans still know ultimately what goes behind these systems, because if they do, then they can engage with the systems in the most efficient way. You get the most out of AI when you already know what's going on in your field of expertise enough to use AI as a tool. And so that's just going to be my hill, is like hill that I'm going to die on, is using AI as a tool and not as a replacement. So workforce is my answer.
Yeah, that's a great point. Yeah. Yeah, you don't, it's important that we have some people who know how it still works, right?
Very much.
Pamela, how about you? What do you think is the most important thing to address going forward?
Oh my gosh, I'm with them. There's so many things. I love both of those answers. I'll say I often I kind of live in the mission space and start thinking about scale. So for me, the most important thing is somewhere between, I think, workforce culture as well as technology. And that's to define what our decision-making processes are from an architectural standpoint and really fundamentally understand what effect we're trying to design for. Because as we start to advance these technologies, it opens new opportunity that humans couldn't do before. And so rethinking the scale and the distribution of when decisions get made throughout the entire process for those large system effects that we're trying to change, either through, the citizen science community or through the war fighting community. I think all of us can appreciate the pervasive interconnectedness that these systems are going to have in the future, and that if we don't understand that interconnectedness, we are either going to fall victim to it potentially, or we are going to, I think, artificially restrain the capabilities in ways that we shouldn't. Because back to that human trust, I think that's a natural human reaction, is to constrain it to something we can understand and we can control. Whereas these technologies are designed to do things that humans can't natively do. And so we have to really start thinking about, I think, scope and scale differently for our systems.
Being comfortable with being uncomfortable.
I say that a lot. I do. I find myself saying that in meetings rooms a lot. Like, I get it, but to push where we need to be, we have to be comfortable being uncomfortable, because we're not ever going to get to 100% answer with these things, either because it's not possible or the mathematics is just not understandable at that level.
Yeah, thank you. So we're about at time. We are at time actually, but I wanted to offer one last moment for anyone to bring up something that we didn't cover today, some final thought you had, or something that you want to leave the audience with in terms of what they might want to look for after watching or listening to our show. And Paul, can I start with you, and then I'll go down the line.
Sure. I think putting on my strategic foresight hat on again, um, it's not going to be possible for us to know exactly what the future holds for AI, although many prognostications are out there. So I think the way that my team approaches it, in terms of um, looking at the uncertainties that exist across the board, again, not just in technology, but also in areas like economics and policy, and being able to kind of structure our thinking, evaluating multiple potential alternative futures, and then deciding across those many futures, is there some kind of choice that I can make that would make me more resilient than not across those many potentials. That would probably be the best way to go forward. So I'll give just a very simple example. I think you brought up in-space data centers before, and I can see there being both some technological and some economic challenges to that. But I can imagine one future in which those in-space data centers become mature and viable and widely used, and that might imply some integration challenges between the AI community and the space community that we need to start looking at ahead of time. And then I can also imagine a future in which those in-space data centers maybe don't pan out the way that folks are anticipating. And one of the implications of that could be that the space AI community may end up lagging behind in certain areas from these, let's say, terrestrial AI community, depending on where the developments are happening. So I like to use that structured thinking approach to figure out, well, what are the different questions I should be asking, and then that'll give me some opportunities to ask the right questions for further study.
No, and that structure you offer is, I mean, that's strategic foresight in a nutshell, right? Is more uncertainty, yay! But yeah, we need people like you thinking about that in terms of what could be and what questions asked. Now, Katie, how about you?
Yeah, so I always put on my policy hat while still, thinking through the technical challenges. And I see liability being a really interesting question that people are going to have to tackle for AI in space in the future. It's also really interesting because I think, there's still some unanswered questions about liability in space systems overall. And so when you talk about increasing use of autonomous systems in space, what is that AI enabled autonomous systems in space? What will that do to the liability regime, especially on an international scale when you're talking about different partners interacting in the same region? So
So
that'll be
give us
really
just a
interesting.
quick, give us a small example of what you're talking about. What could happen?
Well, say if you have an AI enabled autonomous conjunction deconfliction scenario where a satellite moves, but it wasn't necessarily a human operator making the decision, there's a liability regime on an international scale that says, hey, well, whoever's at fault, whoever there's one person who's at fault for this. But when you have AI in the system, it could bring additional questions into who is actually responsible. And so I think it goes back to what Paul was saying earlier, is that at the end of the day, humans are going to be accountable for this. And so how do we design a regulatory regime for AI and autonomous systems that are enabled by AI that allows for all these interesting use cases we've talked about, but still offers protection for people involved?
Yeah, thank you. Pam, how about you?
I think what I'd like to leave people with, and I totally 100% agree with Katie and Paul. I think for me, kind of working in the more application level and development level, I'd like to encourage people to think about these things as a system as a whole and understand that traditional way of designing spacecraft has changed. Software is no longer kind of the last thing. It's not necessarily on the critical path anymore because we have the ability to upload in flight. And so there's a lot of nuances to how we design, test, and deploy these systems that have fundamentally changed based on the technology that's there, but also require that we start testing as a system much earlier in the design life cycle. And that is a very multidisciplinary process and changes, I think, the way that our traditional satellite development teams operate. And so I would put forth that as you start wanting to integrate these advanced technologies, you need to be very open to modifications to your systems engineering and design processes to allow them to be successful and to optimize the value that they bring to the table.
Well said. Well said. Well, thank you guys. I'm really impressed with the variety of perspectives that you guys brought to this conversation. I really appreciate that. And of course, the paper that we have from the Center for Space Policy and Strategy is available at csps.aerospace.org. It's Artificial Intelligence and the Space Enterprise. Taxonomy and Emerging Opportunities by Paul Frakes and Catherine Melbourne, featured here today on the show. So thank you guys, everybody, for joining us.
Thank you for
Thank
having
you.
us.
Yeah, thanks.
To our audience, all of our shows are available wherever you get podcasts. And of course, you can watch the show on YouTube, and you can follow us on LinkedIn. And welcome and thank you to our brand new technical director, Matthew Ricola. Welcome to the show, Matthew. And to our audience, thank you for joining us today. We'll see you next time.